Today we will demo Normal EDA. Normal EDA is an end-to-end collaborative platform for design verification engineers to accelerate their productivity. It generates production-grade verification collateral, such as a test plan and testbench artifacts, directly from complex design specs, accelerating time to sign-off and surfacing edge cases often missed by humans or LLMs. It also produces new kinds of artifacts for project-level understanding, like the ontology and functional graph. To start, click Create New Project, name your project, and upload your design specs. You can also upload any supplemental documents. Depending on whether you are performing IP level or SoC level verification, the environment changes. You can also optionally select a chip template, which dramatically improves the quality of test plan generation for a wide variety of IPs. So what exactly is a chip template? Our automated learning system involves allowing expert users to give feedback on a sample of test cases for a target environment. This teaches the model more about the project type and improves collateral generation for future projects. For example, you'd use a DDR chip template when generating DDR artifacts. Once you click Upload, the auto-formalizing AI model underpinning Normal EDA first works to understand the specs in totality and then starts generating all the key artifacts based on the specs. Additional context is leveraged, if it exists, such as previous revisions of the specs or artifacts. Our model builds an end-to-end understanding of the specs prior to any generation of collateral. For the sake of this demo today, we will show you a fresh project that has already finished generation. When generation is complete, you'll see all the collateral in one place. In this web interface, you can see the test plan, ontology, and functional graph. Starting with the test plan, on the left panel, you'll find a full list of generated test cases. Clicking on any test opens details about the description, procedure, expected results, subtests, and all references from the spec. On the right panel, you can see the exact source test from the specs you uploaded, enabling traceability. You can also view traceability in the other direction, so from specs to test cases, using our Feature Extraction tab. Design verification engineers measure test plan completeness by highlighting sections of the specs that are testable and then checking whether existing tests cover the specified functionality. Our goal with this feature extraction capability is to mimic exactly that workflow. If you want to add a test, you can do so manually by clicking Add a Test Case, or you can do so by leveraging AI-assisted actions. In the second part of this demo, we will introduce the normal CLI. While the front end generates useful artifacts, the other set of time-consuming design verification workflows involves writing code, running simulations, and closing functional coverage. To address this, we provide a command line interface that works within the context of your existing test bench, adapting to your codebase and simulation environment in real time. It interprets any existing scaffolding and plugs into your current drivers, scoreboards, and simulation tools without disrupting established workflows. Since we're using our own simulation server for this demo, we're showcasing Normal CLI using our own DDR3 test bench. But it's important to note that the same AI agent workflow applies universally. Let's generate stimulus for one test that doesn't yet have stimulus. To start, you first initialize the agent. The init command allows the agent to perform exploration of the test bench to learn the in and outs of its structure. When it finishes, it will output a normal.md file describing the test bench. Now that the agent has learned about the test bench, we can start to generate stimulus. Let's generate stimulus for the MPR timing parameters test. The agent parses and understands the test bench structure, autonomously runs compilation and simulation, and then uses the outputs from the simulation tools to improve its outputs. Once the agent finishes, it actually generates SystemVerilog files in the sequences and tests directory. You can see an example of the stimulus generated here. The generated stimulus adheres to your project's style hints and existing library imports to ensure the generated code is immediately executable. If you're starting a project from scratch, you can also use Normal CLI to generate a reference model. This command creates a SystemVerilog module in the RTL folder representing the BFM itself, along with a lightweight test bench for validation and a makefile to run the test bench against the BFM using the SystemVerilog simulator. Another task you can perform in the normal CLI is directly prompt the CLI in natural language. This allows you to easily make changes to your generated collateral or analyze the test bench for further understanding. Let's say I want to ask Normal CLI to explain in natural language to me the purpose of a test. You can see the results at the end of the agent trace here. In general, Normal CLI can be steered to put code and updates wherever you want it. So if you have a custom version control workflow or want to report progress to a project management system, it's just a matter of editing the normal.md file to add the relevant commands and instructions. Normal EDA unlocks more efficient and higher quality verification so teams can design and verify new, more radical ideas with confidence.
I was very surprised because it reduces the complete setup time. So you should just give you the specification as an input, and it itself generates the stimulus as well as the blocks required. So the engineering effort that I should put into the coming up with all the driver code or to the agents is completely reduced. We are just giving the spec and it's automatically generating the test cases, which is very good because based on the spec it is going to come up with all the test cases, even the corner cases. So that is very good because human effort is reduced a lot. Things we might check instead of spending our times in generating the test cases. So it is reducing our effort in terms of verification because the test case is automatically generated and the test bench architecture is generated. Human is in the loop because he is giving his inputs. As a verification engine, I can spend less time on verifying things basically because the tool is doing on its own and it's showing me the results. So I can shift my mind towards the design and I can spend time towards that.
As engineers, we usually love to code rather than documentation, and you have a beautiful documentation which is straightforward. So I like that a lot. The output from the AI model, it's like a weeks of work from our side. So that was amazing. And then human language, it understands and gives output based on that. So that too is interesting. We can save time on that.
I'm amazed by the test plan generation because that's the start of any DV and it has to be in proper format, and also it should close well. I mean, it should be in a structured way. And second is that you can go and change the constraints, change the prompt, and again rerun the test sequence. We'll have the test plan already done, and also if the test bench structure is there and the tool generated test plan is there, stimulus can be generated and team can spend more time debugging the actual failures in the RTL. So this way the team can save time.
If error comes, how much we will spend time for debug actually. So that time was immensely reduced to very few minutes. So I can focus on the main thing which is debugging actually, not on the run part, simulation part.
My initial reaction was wow, AI is thinking, and as a verification engineer, AI is thinking and giving me a report of what test cases we have to write and how I have to. AI is thinking, and the tool is thinking and telling where exactly, how many errors figured out in log file. So it was wow for me too, because whatever I am doing, the AI is giving it in a minute.
Normal EDA will only keep getting better from today. As we scale our unique AI and physics-based methodology with our partners, our AI will continue to learn about the physical world and enable faster, higher quality, and radically new approaches to custom silicon.